This is a trigonometry 3D, and it is both a pyramid and a box. It's a pyramid above a box. So, but we don't have to worry about that. We can do this separately. First of all, we have to find GE. So this is G and E is over here. So let me show you in 3D over here. So this is the picture. So what we have over here is we have this paperweight of a shape, and this is a box, and above the box there is a pyramid. The angle that we have to find, if we see this like this, the framework, just the framework. So this is what it is. So the angle that we have to find, it's from here, from G to E. If we take a look at this side, it is going from this point over here to E. So this is it. This is the idea. So we have to find the length of GE. So for that, we need this right angle triangle. So it's 90 degree over here. So we have to use the triangle GIE from this triangle. So when we use that, we can easily see that using the Pythagorean theorem, we can find the length of GE. So let's start. So question number A1. So from the triangle GEI, we know EI is 4 because this is 4, so this will also be 4. So this is 4. Now we need GI. Now we can find GI from the diagonal because we know base is a rectangle, so this is GI. So GI and this is H. So that means this is 16 and this is going to be 12, because if this is 12, this is also going to be 12, this is going to be 12, and if this is 16, this is going to be 16. So this is 90 degree. So we can write in triangle GHI, using the Pythagorean theorem, we have GI squared equals to 16 squared plus 12 squared, and this turns out to be, so 16 squared plus 12 squared, the square root of 400 is going to be 20. So this is 20. Therefore, GI equals to 20. Now that we know that GI is 20, we can use this triangle, this right angle triangle. In triangle GIE, GE is the hypotenuse, G square equals to 4 square plus 20 square. So this is going to be 20 square is 400. So this is going to be 416. Therefore, GE is going to be square root of 416. We don't have to worry about plus minus over here, plus minus square root, because this is a length. The length cannot be negative. So square root of 416, and it's going to be 20.3. The answer has to be the three significant figures. So 20.396. 20.396. Answer would be GE equals to 20.4 centimeter. Remember, we might need this for the next sum. Otherwise, if we just use the three significant figure answer, there would be rounding error. Question number 2, we have to find AB. So now AB deals with one of the sides of the pyramid. Now we have to think about this separately. So we can think of this like this. So we have to find AB width. We can take this right angle triangle. So this is the height of the pyramid. So this is AB, and this is half of the diagonal. Now remember, the diagonal of the rectangular base of the box is the same as this because they are the same rectangular base. So the diagonals are going to be the same, and if you know the height of the pyramid, we can easily find, using Pythagorean theorem, the length of AB. So what we can do over here, we can write down this triangle A. We call this base of the height X. Let me call this X. This is 90 degree and this is B. So we know BX is half of the diagonal. So if the diagonal is 20, BX is going to be 10. And let's see whether we have information regarding the height of the pyramid. Well, the height of the pyramid is 8 centimeter. Just the pyramid, not the entire from the top to the bottom, just the pyramid. So we can write this as 8. So we can write in triangle AXB, always mention the right angle letter at the middle, AXB. So we can write AB squared equals to 10 squared plus 8 squared equals to 10 squared is 100. So 8 squared is 64, 164. Therefore, AB equals to square root of 164, and that is going to be square root of 164, that is 12.806. 12.806, and the answer is going to be AB equals to 12.8 centimeter. Question number B is angle between side and FGHI. So FGHI, that is the ground. FGHI is the ground. So we have to find the angle between GE and the ground. That means it is going to be this angle over here. We already know what GE is. It's going to be this angle. This is 90 degree at this corner over here at I. So the angle between GE and the ground is going to be this angle over here. So let's do this. This can be done very quickly. So in question number B, we can write, we're going to use this triangle. This triangle. This is the angle we're looking for. So we mentioned the triangle. In triangle GIE, this we can call this theta. So tan theta equals to opposite, which is 4, divided by adjacent, which is 20. Therefore, theta equals to tan inverse of 4 by 20, which is 1 by 5. So it would be tan inverse of 4 divided by 20, and it is 11.3099. So 11.31. So the answer is going to be, so the nearest one decimal places. So the angle between GE and FGHI is 11.3 degree. Now we have to find the angle between AB and the floor. That means in this case we have to find the angle of the pyramid, this side AB and the base of the pyramid. That means the angle is going to be this one over here. So this is AB and this is the base of the pyramid, BCDE. So what we take is, we take the height of the pyramid and we take half the diagonal, and this is the angle over here, angle ABX. That's the angle we need, and that is the angle which is the angle between the side AB and the base of the pyramid. So we can do this over here very quickly. So in triangle, this is the triangle. So in triangle AXB, we can again, let me call, previously we called it theta, let me call this alpha over here. So tan alpha equals to opposite 8 divided by 10. Therefore alpha equals to tan inverse of 8 by 10, and that is going to be tan inverse of 8 by 10 is 0.8, and that is 38.66 or 38.7 degrees. So this is going to be 38.7 degree. We are almost done with the sum, and the final one is usually the most difficult. So here we have to find the angle between the plane ABC. So the angle between the plane ABC, that means this is ABC, this is the plane, and the plane BCHI. So that's a bit different because that plane is going to be BCHI. So it's going to be this plane. So the difference from the previous sum and this one is that one of the side is part of the pyramid, one of the plane ABC is part of the pyramid, and the other plane is part of the box. So this is what it looks like. The angle has to be between one face like this and the other. So it has to be between ABC, this one, and BCHI, this one. So it's very difficult to find out the angle, and it's easier to do so in two parts instead of doing this in one part, because otherwise how do we do it? We take this side and then this side. It's a bit difficult. But if we take this into two parts and have a floor over here like this, in this situation what we can do is we can think of this base BCDE, and we can find the angle of ABC and this base, so that becomes the angle between a triangular plane and a rectangular plane. That is easier. In that case we can take the height of the pyramid like this. We can take the height of the pyramid, and we can take this one, half of this. If this is 12, this is going to be 6, and the height of the pyramid is 8, and we can find this angle. So this could be the first part. So the first part will be the angle between the plane ABC and the floor of the pyramid, and then we can proceed. So let's do this step by step. So the first part would be, so question number D. So what we can do, we can take this triangle, this is X, and this is A, the tip of the pyramid, and this is going to be the midpoint of BC. So let me call this Y. So this is the height, 8, and this is 6. 6 is half of 12. What is this? This side is 12, and if we take half of that, that is going to be 6. So let's find this angle first. So this angle, we can call this theta 1. So in triangle AXY, tan theta 1 is opposite 8 divided by adjacent 6. Therefore, theta 1 is tan inverse of 8 by 6, and that angle turns out to be 8 divided by 6. Tan inverse of this is 53.13. So this is going to be 53.13 degree. We found the first part. Now the second part goes like this. Now we have to think about the angle between this one, the floor of the pyramid, and this slanted, this inclined plane. We have to find this, and this is the same as this angle over here. B, this angle over here, angle B, so it can be IBE. This is the angle. This is the angle we're looking for. And it's pretty straightforward to find this angle, and we can add this angle and this angle together. So let's finish this. So this is going to be, so this is 12, so this is B, this is E, this is I, and what is the length of this? Okay, so this is 4, this one is 4, and this one is 12. We can find the angle very simply. So this is 4, this angle is theta 2, so we can write in triangle BEI, tan theta 2 equals to opposite by adjacent. Therefore theta 2 equals to tan inverse 4 by 12. So that turns out to be 4 divided by 12. Tan inverse of that is 18.43. 18.43 degrees. So the answer, the angle between the two, theta 1 plus theta 2 to three significant figure, is going to be 53.13 plus 18.43, and that is 71.6. So the final question, it's actually not a single question but two questions, one between a triangular plane and the base of a pyramid, and the other one a rectangular plane with another rectangular plane, and we have to add up the two angles to find the answer.